Hello. In this video, we are going to begin learning about piecewise and step functions. Well, we're going to continue learning, but in a different way. So, piecewise functions, we've looked at those before. We know that it's one function that is defined differently over its domain. It has different domain restrictions, and in those domain restrictions, it is associated with a different definition for the function. So, let's look at this function that we have here. X plus 3. We want to graph that line. So we know our y-intercept is 3. And we are going down, up 1 over 1, up 1 over 1. Or down 1 to the left 1, down 1 to the left 1. But this graph is only when x is less than 1. So we need to shift this graph. And it's less than 1. It's not equal to 1. So we're going to have an open circle there. Our next function is 2x. So its y-intercept is 0, its slope is 2, up 2 to the right 1, up 2 to the right 1. And this is when x is greater than or equal to 1, so we need to move that function up. It is equal to 1, so we have a closed dot. Remember open dots and closed dots way back. You started learning those when you started graphing basic inequalities. Open does not include, closed does include. So that is a piecewise function. When you graph it, you graph the function and then you move it. They do get more complicated. We're not going to get more complicated right now, though. So, because they can start including different function families, like you can have a linear function and a quadratic function and an absolute value function all in one piecewise function. And it's great. So now we're going to move on to step functions. Step functions are just special piecewise functions. So this looks like a piecewise function, doesn't it? Okay. Step functions are just piecewise functions, but they, instead of having different lines, they have horizontal lines. Here's one function family. It's constant functions, just multiple. Just like the one we looked at was a linear function, and it only had linear functions. These only have constant functions, and meaning that the slope is constantly the same. The length of the lengths may be different in some cases. Most likely they're not different, but here we go. So we know that for our first one, our constant is 3, and that's in between -1 and 1. Now, you're probably thinking, what in the world is that little diamond doing on the end of Miss Jordan's line? Microsoft does not allow me to put an open circle as an endpoint, but Microsoft does allow me to put a diamond on the end of that line. So just know that the diamond indicates an open circle because that is what Microsoft allows me to do. And we have the closed circle at the beginning at -1 because it's -1 is less than or equal to. It includes. It's equal to -1. So we have a closed circle, but x is just less than 1. It does not include 1, so that's an open circle, or in this case, a diamond. Our next constant is 4, and that's from 1 to 3. It includes 1, but it does not include 3. So we have a closed dot at 1 and a diamond at 3. Remember, the diamond is an open circle in this instance. And lastly, our constant is 5 in between 3 and 5. We have a closed dot at 3 because 3 is less than or equal to x, and then less than 5, so that is going to be an open circle. So step functions are that. That looks like steps, right? Looks like steps. That's why we call it a step function. All right, greatest integer functions. We're not really going to dive exactly into what a greatest integer function is too much. I am going to tell you it rounds any number down to the nearest integer. Integers are whole numbers, positive or negative, and it's just a special step function. It's what it is, a special step function. So the greatest integer notation is this bracket, but it's missing the bars at the top of the bracket. So anytime you see that, at least now you will know it is greatest integer. And what that means is it translates so that function is all real numbers, essentially, for its domain. But if we restrict the domain to only in between 0 and 3, we can then begin to evaluate this. So if we go to graph this, any number that's in between 0 and 1, but it's not equal to 1, so 0.999999999 is going to round down to 0. So that means we need a line right there, okay? It's not 1. Anything that's up to 1, that is approaching 1 but not 1, or anything down to 0. Our next value is 1 for anything that is a 1 all the way up to 2, but not including 2. So 1.9999999999999. Get it? Okay. Not quite 2, but as close to 2 as you can get is going to round down to 1. And lastly, our constant function is 2 because it's anything including 2 all the way up to, but not including 3. So 2.99999, y'all knew I was going to say that. So we have 2 to 3, and that is our greatest integer function. It's just a special version of step functions, just something to throw in there just so you're aware of it. And that includes this, I'm still saying includes. That concludes this lesson on piecewise and step functions. In our next video, we will continue investigating functions and diving into functions. So I will see you then.